Alright guys, in this video we're going to talk about fractional exponents and work through some examples. So the first one I'm going to do is 27 to the 2/3 power. Alright, so how do I go about handling this problem? Well, if there is any number in this numerator besides 1, then I'm going to have to rewrite that fraction to have 1 in the numerator. So I know that if I say 1/3, so I change that 2 to a 1, keep the denominator the same, times 2, the original numerator. If I multiply that, that's going to give me 2/3, which is that fraction. So this is how I'm going to break it up. So I bring down the 27, and I'm going to take it to this 1/3 power, put it all in parentheses, and then take it to that second power. Now I need to work everything in the parentheses first. So anytime I take a number to the 1/3 power, that's the same as taking the cube root of that number. And it looks like this. You can put that in the calculator, or you can say, what number multiplied by itself 3 times will give me 27? And the answer is going to be 3, because 3 times 3 is 9, times 3 is going to be 27. So it's 3. Now don't forget, that was what was inside our parentheses. We still have to take that answer and do it to the second power. 3 squared is 9. So your answer is going to be 9. Okay, let's do another one. Alright, let's do 16 to the 5/4 power. Now, keep in mind, even though this is an improper fraction, so the numerator is greater than the denominator, we'll still do it exactly as before. So I change that top number to a 1, keep the denominator the same, times it by the original numerator. And that's going to give me 5/4, so that's how I'm going to break it up. I bring down my 16, do it to the 1/4 power, put it all in parentheses, and then take it to the 5th power. Alright, so now I need to handle what's in my parentheses first. So what number times itself 4 times will give me 16? Well, it's 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's the same as taking 4th root of 16. And that's how you could put in the calculator. 2, and then we'll take 2 to the 5th power. And 2 to the 5th power is going to be, let's see, 2 to the 4th power was 16, so 2 to the 5th power will be 32, because 16 times 2 is 32, right? Okay. Yep, okay. I want to make sure. Okay, let's try another one. So let's say I have the cube root of 3 and then 8 squared. So how do I go about this problem? Well, the first thing I need to do is I need to get it out of this radical form, and I can rewrite it in my fractional form. So this number inside the radical is going to be my denominator, and this number, wait, let me make sure I'm saying that right. I want to tell you wrong. Yeah. So the number inside the radical is going to be your denominator. I'm sorry, your numerator, and this number outside the radical is the denominator. So let me show you what that looks like. So I'll write that out. So this number inside the radical will be your numerator, and this number outside the radical is going to be what becomes your denominator. Okay. So I just bring down the 8, which is my big number. And then I put 2 in the numerator and 3 in the denominator. And that's how I do it. So now I can work it like I did the other ones. I can say, I can break that up to 8 to the 1/3, 1/3, to the second power. And so I find the cube root of 8 and then square it. So same thing. So I just want to show you that this number can be taken out and put as the denominator in your exponent, and the number inside the radical can be taken out and put as the numerator. Okay. Next one I'm going to do is just to show you what to do when you have pretty much any negative exponent. So if you have a negative exponent, and it doesn't matter what it is, it can be a fractional exponent, it can be like this. Either way, you're gonna rewrite it because you can't have a negative exponent. So how do we rewrite that? So the way we do it is we make a fraction and we put 1 on top, and then we put this number on the bottom but change the exponent to positive. And we do the same thing here. We make a fraction, we put 1 on the top, and then rewrite the number with a positive exponent. And that always works. So then it's a lot easier to solve, because then I can just solve this in my denominator, and whatever my answer is, I'll just have 1 over it. And so that will be the answer. Okay, so let's see. Another thing I do want to mention, so if you have one where, well, there's an understood 2, but I'm going to write the 2. So let's say you have x to the third times cube root of x to the 5th. So now we kind of know how to work with these. So we know that this number is going to be our numerator, and this number is going to be our denominator. So we can rewrite it as x numerator 3 over 2 denominator times, same thing, numerator over denominator. So anytime we have a common base, and x is our common base, so it's x and x, so they're the same. So they have to be the same for this rule to apply. But if they're the same and we multiply, we can add these exponents. So I can add 3/2 plus 5/3. Now, you could, of course, put them in the calculator, but the proper way to do it would be to change these denominators to the same thing, because we can't add fractions with unlike denominators. So how could we change them to the same? Well, we can find the least common multiple of 2 and 3, which is 6. So I can multiply this times 3 and this times 3. That's going to give me 9 over 6. I can multiply this times 2 to get 6, this times 2. That's going to give me 10 over 6. Well, now I just add the numerator, so 19, keep the denominator the same. So that would be the answer for that. And of course, it would be x, the official answer would be x to that power. And then you could probably simplify that even further. Okay, so I think there's one more thing I want to mention. Yeah, so in some cases, we'll be given something like this, and your teacher may want you to simplify it. So the way you look at this is you say, okay, how many times does 12 go into 31? So it goes into 31 2 times. And 12 times 2 is 24. So I'll write it like this. I'll keep the 12 the same. I'll put x to the 24th. Then write another one, leaving x there. And then put what's left. So what is 31 minus 24? Well, it's 7. So I'll put a 7 here. So that's kind of how you simplify that. And actually we could pull a 2 out, so we could say x squared times x to the 7th. Alright, I hope that helps, guys.